If you are feeling overwhelmed by the alphabet soup of AI terminology, LLMs, generative models, deep learning, the confusion usually stems from how these terms relate to each other. Artificial intelligence represents an entire field of study. Inside that is a subfield called machine learning. It uses historical input data to train a model to make predictions. For example, using past Nike shoe sales to predict future Adidas sales. These tools function as stacked layers of statistics, using past data to anticipate what happens next. Within machine learning, there are two primary ways models learn. This split screen shows the first method, supervised learning. Here, human operators feed the algorithm clearly labeled data. For instance, we track historical restaurant bills, explicitly labeling whether each order was for pickup or delivery to predict the final tip amount. The second method is unsupervised learning. Over on the right, we feed the model completely raw, unlabeled data, like employee tenure and income. Without any human guidance, the model scans the raw points and naturally groups them into distinct clusters, revealing different career tracks. After making a prediction, the supervised model checks its work against that human-provided answer key, adjusting itself if it makes an error. The unsupervised model operates independently, discovering structures without a pre-written answer key. That initial choice, whether or not humans provide an answer key up front, dictates the entire training path for the algorithm. Stepping one layer deeper into our map, we find deep learning. This is a specific type of machine learning powered by artificial neural networks, built with layered nodes and neurons inspired by the human brain. This layered structure enables semi-supervised learning. A bank looking for fraud might only have the time to manually label 5% of its transaction data. The deep learning model studies those few labeled examples, learns the basic concepts of fraud, and then automatically sorts the remaining 95%. By leveraging small samples to organize vast amounts of raw information, deep learning eliminates the massive bottleneck of manual human labor. Inside that deep learning layer, the technology splits into two very different branches based on what the model actually does: discriminative and generative. A discriminative model studies the relationship between data points to categorize information. You feed it a photo, and it tells you whether it's looking at a dog or not a dog. It classifies existing data. A generative model studies underlying patterns. Instead of categorizing, it takes a text prompt and uses the patterns it learned, 2 ears, a tail, fur, to assemble a completely new, original image of a dog from scratch. Let's test this. If an AI tool scans your inbox and outputs an 80% probability of spam, which branch is it using? It is a discriminative model. Here is the rule. If the output is a number, a probability, or a classification tag, it is not generative AI. Knowing whether an algorithm categorizes old data or creates new media lets you instantly identify the underlying architecture of any tool you encounter. Now look at how this all maps out. Large language models, or LLMs, sit right at the intersection of deep learning and generative models. They pull from both domains. To make an LLM useful, it goes through two phases. First is pre-training. You feed the model massive amounts of broad data so it becomes a generalist, like teaching a family dog basic commands. Then comes fine-tuning. You feed it a highly specific, targeted dataset so it becomes an expert, like training that same dog for police work or search and rescue. This structure explains the modern AI economy. Tech giants spend billions pre-training massive generalist models, and smaller companies buy access to fine-tune those models with their own specialized industry-specific data. Let's put the entire map together with a single real-world scenario. Imagine a hospital purchases a generalist pre-trained large language model. To make it useful for their doctors, the hospital takes thousands of human-labeled medical records and uses supervised learning to fine-tune that model into a healthcare specialist. Once deployed, the hospital uses the discriminative side of the model to scan X-rays and classify abnormalities, while relying on the generative side of the model to write out novel patient summaries. 3 operational principles define where any tool sits on this map. 1. Labeled data indicates supervised learning. 2. Outputting numbers indicates discriminative. 3. Outputting new media indicates generative. Once you grasp this hierarchy, the intimidating buzzwords of AI resolve into a predictable, logical ecosystem.